In this video, I will show you how to evaluate this line integral. So first, we have our vector field here, and our curve is a triangle. And let's go ahead and make a sketch right here real quick. We go from 0, 0, and we go to 0, 4, and then we go to 2, 0, and then we go back to the origin. So we are going like this. That was bad. We don't go off track. But anyways, here, here, and here. Now notice, which direction is this? This is the clockwise direction, which is considered the opposite orientation. So in fact, we will have to negate the result that we're about to get. And notice that here we have a closed curve, so we can actually use the Green's theorem because this vector field is very nice. There's no singularity, there's no xy on the bottom and whatnot. Absolutely no worries. So we'll use the Green's theorem, but first let me just indicate that we will have to negate the result. Again, it's because we're traveling in the clockwise direction, which is the opposite orientation. And maybe you want to say this is negative c, that's fine too. But as long as you negate it, it's fine. Anyways, this right here, by Green's theorem, we can change into a double integral, and then we'll have a little r here. Now we have to remember, inside we do partial derivative. We look at this part right here first. And this is usually denoted as q. And we are going to take the partial of q with respect to x. Remember, it's always the opposite, because this is like the y component, you do the opposite. Yeah, so you have the partial with respect to x. And then you are going to minus the second part, which is this. That's usually denoted as p. And then we'll take the partial of p with respect to y. And then we will have dA on the side. Now, let's just go and figure out the partial derivatives. So for this, we look at this and take the partial with respect to x. The partial of this with respect to x is 1, and we will have y. Here, take the derivative with respect to x. We need the product rule. So x times the derivative of the second plus the second times the derivative of the first. So it's just 1, doesn't matter. That's it. And then we are going to subtract partial p with respect to y. Okay, the derivative of y here is 1, so we have cosine x left. And then this is actually really nice, because y is right here. Take the derivative, you get 1. So we have minus x sine x. Quite nice, huh? And you will see a lot of things will actually cancel. In fact, you can see here we have negative sine x times x. And this is also the same thing. And we are subtracting. So this and that out. And in fact, we have what? Cosine x minus cosine x. So this is also out. On the inside, we actually just have y. So we actually get a negative double integral of y dA. Now, for the dA, it depends on how you want to do it. Here we have a triangle. In my opinion, it's easier if you go with dy dx. And hopefully, usually, this right here, it's not so bad. dy, because you are looking at the bottom function first, and then to the top function, y as a function of x. We are much more used to that, right? So dy going first is easier. Anyways, the bottom function is y equals 0, so we will have 0 here. As of the top function, here we have a line, y equals mx plus b. What's the slope? We go down by 4 and we went to the right by 2, right? So it's negative 4 over 2, which is negative 2. So m is negative 2, and then the x, and then the b is 4. That's the y-intercept. And you can plug in 2 into here. Negative 4 plus 4 is 0, so we get back to the x-axis. So this is the equation. We write down negative 2x plus 4. So bottom function, top function. Now, left number, right number, x value, 0, 2. So this is 0 and then 2. And then just pretty much do the rest. Integrating this, we will have y squared over 2, so like this, and then we plug in, right? Yeah, and then dx, and plug in and do the work and all that. So if I plug that in, I will be getting, let's just do the algebra on the side real quick. That's 1/2 times negative 2x plus 4 and then squared. Depends how you want to do it. I can factor out a 2, well actually a negative 2. So perhaps it's easier, negative 2, and then that will give us x minus 2. Yeah, and then I will square this and then I'll square that. And that's 4 over 2 is just 2, and then expand this, I get x squared minus 4x plus 4. Okay, I have the 1/2 in the front here, so we will have the following. We will have the 2, can put all the way to the outside. Here we have the negative, don't forget about that. Negative 2, and then we have the integral from 0 to 2, and then this right here, x squared minus 4x plus 4. In fact, I just noticed it will be easier if you just keep it like this in terms of the integration. So I will actually just do that. So let's don't do this. This right here is a 2, and then on the inside, I'll keep it as x minus 2 squared, and then dx. The reason for us to do this is so that you can just do a u sub real quick. Let this equal u. So du is the same as dx. You don't have to divide by any number. So integrating u to the third power, you will just get u to the, integrating u to the second power, you get u to the third power divided by 3. So we have negative 2 over 3. And then u to the third power, right? But u is what? U is x minus 2. And then third power. And then at the end, we just have to plug in numbers 0 to 2. Plugging 2, you actually get 0. That's very nice. And then we have the negative, right? So it's technically 0. And then minus here, we have the negative 2 over 3. And then plugging 0, and then we will just get negative 2 to the third power. Okay, this is negative 8. That's positive 16, but negative. So altogether, we have negative 16. And then on the bottom, we have it over 3. And that should do it.